Hello students and welcome back. Let's solve this basic problem that says determine the horizontal and vertical components of reaction at pin A. So our pin A is right here, and the reaction of the rocker B on the beam. So this is our rocker B. Okay, so we already know this is one is pin joint support and other is the rocker support. um, from the previous lecture we did find out when we had a pin support, it is free to rotate but it does not allow the translation in both x and y direction, or in other words there will be a reaction force parallel to the surface and also reaction force perpendicular to the support surface. So let me call this as FAX, and then this will be FAY because it is applied at pin A or point A. Now for the rocker support, we already know it behaves as in a roller support where uh, it is free to move along the surface, so there will be no reaction parallel to the surface. Also it is free to rotate, so there will be no reaction moment, but uh, it will have a reaction, the force perpendicular to the support surface, because it is not allowed to move up and down in this case. uh, I will call this as FB, or the force applied at B, although this force is not vertical, not horizontal. So what we need to find is the horizontal and vertical components. So FB is not either horizontal not vertical, so in fact we what we would need is to find out the reaction or the components of this force, that would be horizontal and vertical. uh, let's draw a free body diagram of this case so that we can actually see what I mean. Okay, so we isolate the body. This is my body. Let's say this is point A, and then we have point B to make things simpler for us. And we have forces, so we have one force as FAX, and then we have another force that is FAY. Okay, and additionally we have another force that is actually acting at an angle right here, and I called it as FB. But what we need is horizontal. We need horizontal and vertical components. So this force will have two components. One will be the horizontal component. I will call it as FBX, and then there will be a vertical component that will be FBY. Okay, although we would need to find out those components, which would come in very handy, would be the angle that FB makes with the vertical axis. So this would be important in order to find out these components. Okay, so first of all we need to figure out that angle. All right, now what we know is from the figure that this angle with the surface or support surface and horizontal is given. Okay, so from the figure we can see that the angle between the support surface, which let me draw it here. I can draw it like I will just call this point as this is actually this point. Let me call this point as point D. Okay, so point D, and then I have a horizontal surface that is this one. Let me call this as E to keep things clear, and I will call this as F. Okay, so this angle in the figure is given as 30 degrees. Okay, let me write it a bit smaller so we can have more space. So this angle is 30 degree, that is given right here. Okay, now another thing that is known is that the force FB is applied at an angle. Okay, but we already know that this force will be perpendicular to the support surface. For a roller support it should be perpendicular, so that means the force FB that is applied, okay, it is perpendicular, so making an angle of 90 degree with the uh, with the line DF. Okay, this is my FB. All right, now what we need is we need to find out the angle. So which angle do we need to find out? We need to find out this theta. Okay, which is the angle between the vertical axis and the force B. So that means that we need to find out this angle. If I draw it, let me draw it dotted so keep things clear. Okay, so I need to find out this angle theta, which is actually the angle with the vertical axis and FB, as you can see from here as well. So it is the angle between the vertical axis and the FB. Okay, now there is a concept of corresponding and alternate angles. Let's discuss that first so we can make things very much clear. So whenever we have two lines intersecting, so we say that these two angles will be equal. Okay, and also we can say that this angle and this angle are equal. These are called the corresponding angles. Okay, this is one concept. And then the second concept is that whenever you have two horizontal lines and you have some other third line intersecting them, okay, you have some third line intersecting these two lines, then your alternate angles will be equal. So alternate angles is like this angle and this angle. These are the alternate angles, they will be equal. Similarly, the other alternate angles are these ones, so they will also be equal. So if you don't know what are corresponding and alternate angles, try to check some tutorials where you can understand this concept. Okay, so using the same concept, I would try, because I have a line DE that is horizontal, and I would like to draw one more line that will be also horizontal but at point, let me call this point as G. Okay, I will try to draw one more line at point G, and that line will be horizontal as well. So I will draw this one more line and it will be horizontal line at point G. And we see that there is a line D and F that is intersecting this. If this is a line E, then the line DF is actually intersecting these two horizontal lines. Okay, so let me call this as small a and small b, and then I can call this as to make things easier, I will make this as capital A and capital B. So these two are horizontal lines, and this line EF is actually intersecting it. That would mean that whatever this angle is, the 30 angle shown here, okay, this angle 30, this one, okay, this angle will be actually equal to this angle right here using the alternate angle theorem. So this will also be equal to 30. Okay, also we did see that FB is applied perpendicular to line EF. Okay, since it is perpendicular to the line EF, then our this angle was 90 degree. This total angle is 90, and that is why if you want to calculate this specific angle, then you have to subtract the 30 from 90. So this will be actually given as 60 degree. Clear? Also we see that this this line, this dotted line, which is a small a small b line, this one is actually horizontal, and our dotted line, this one, this dotted vertical line, this line is actually vertical. And that is why when we have this kind of case, so they are kind of a 90 degree angle. So our this angle, total of this angle will be 90. Okay, so this will be actually making a 90 degree angle, and we know that one side is 60, so this we can actually find out this theta by subtracting 60 from the 90. So this theta will actually become equal to 30 degrees. Okay, because total is 90, so you remove the you subtract the 60 from it, you get the 30 degree. So this is the angle that we are actually looking for. So we get the value of theta to be 30 degrees. Also, you do not need to do all this calculation. Usually when you have a surface something like this, and you have FB applied perpendicular to the surface, so whatever the angle is with the horizontal, you get the same angle with the vertical. You can even remember that. Otherwise, if you don't remember or you are confused, you can do this analysis to find out the angle theta. So this is important, that can come up in the upcoming problems as well. So just to needed to go a little bit in the detail of how this angle theta come out to be 30. All right, now let me clear this up so we can actually have more space to solve our problem rather than talking about the angle. Okay, now the rest of the problem is here. I forgot to put this force here, which is actually 4 kilonewton. And in the free body diagram, keep in mind you must mention the distances as well. So that is actually 6 meter, and then you have 2 meter. All right, now we need to do is we need to find out the forces. Let's see. From the free body diagram, we can see that the sum of as the equation of equilibrium, which states that the summation of forces in x or horizontal axis will be equal to 0. Summation of forces in vertical axis will also be equal to 0, and then summation of moments about any point should be equal to 0. These are the general equation of equilibrium conditions. So we must remember these by now. So using the summation of forces in y-axis, we know there are 3 forces that are acting in y-axis. One is the FAY, then I have FBY, and finally I have the third force as the 4 kilonewton that is also acting in the y-axis. So these 3 forces are acting in the y-axis. So I will just write their sum equal to 0. So I have if you either take the sum equal to 0, okay, or you just take the forces acting upward and equal it to the forces acting downward. So I will do that. I will take the forces acting upward, there are FAY and FBY, and make it equal to the force that is acting downward. Okay, it doesn't matter which one you take, positive or negative in that case, because you have to take all of those positive when you are dealing that. Otherwise, if you take sum of forces equal to 0, so in that case you have to take one of them as positive and then the other one as negative. It's the same thing. So I will call this my equation 1. Now in this equation we cannot solve it because there are 2 variables, 2 unknowns. Okay, so I will move on to a second equation. Now that would be for the moment, summation of moment. Now I can take either point A or point B. Let me take point B because there are some angles involved. I don't want to be involved in that, so I will just take summation of moment about point B equal to 0. And I'm doing that because this force FB is passing through the point B, so it will have no moment about point B, and that is why I will be left with the forces that are horizontal and vertical having moment. So if I do that, now what are the forces? Now if I look at it, FB will not have any moment. That means FBY, FBX will not have any moment about point B. They have no momentum, so they will have no moment. The FAX is also line of action passing through the point B, so FAX will also not have any moment. I will be left with FAY that has a perpendicular distance of 8 meter from point B, and also I will be left with the 4 kilonewton that has a perpendicular distance of 2 meter from point B. Now FAY is actually creating a uh, clockwise movement. Okay, so I will take that as positive, FAY, and multiplied by the momentum, which is 8 meter. And then our 4 kilonewton is actually creating a moment that is counterclockwise, so that will be taken as negative. Okay, so I will take it as negative 4 times the momentum, 2 meter, so it will be equal to 0. And in this equation actually we have only one unknown, so we can simply find out FAY, which is if I calculate it, so 4 times 2 will be 8, it goes on the other side and then it get divided by 8, so you are left with 1 kilonewton. So we found out our first vertical force, which is FAY, this one moving upward. That is good. And next what you can do is actually put that in equation 1. Okay, since you have in equation 1 you found out one unknown, and then you can find out the next one using the equation 1. That will actually give you FA1 is let's see, from equation 1, so FAY plus FBY is equal to 4, and you can put the FAY to be 1 plus FBY is equal to 4, and your FBY becomes, so 4 minus 1, that is 3 kilonewton. So we found out our second force as well, and that is the vertical component right here. So we found this one. All right, now it is very important that we found FBY, because we see this triangle, the green triangle, where we have FB as one side, FBX as the other side, and FBY as the third side. And we also know the angle theta, which is equal to 30 now. Okay, so for a triangle to be solved completely, I mean for the right angle triangle to be solved completely, if you know two things, you can find out all the things. Okay, so we know one vertical force, we can actually find out the second force, horizontal force, FBX, solving this triangle. Okay, so let's do that. Let me redraw this triangle here. Okay, so here is this triangle. I have FBX, then I have FB, and FBY, now we know what is equal to. It is equal to 3 kilonewton. Okay, so this is actually 3 kilonewton. Okay, and this angle we already know, this is 30, although it does not look like 30, but it is actually 30. We calculated that. Okay, uh, now we can actually calculate or find out the FBX using the trigonometric ratio. So keep in mind that whatever angle you are using, this will be perpendicular and then this will be base. So perpendicular is FBX, base is 3. Okay, and whatever trigonometric ratio is that is involving both base and perpendicular, we have only two trigonometric ratio. One is the cot theta, and then we have a tangent theta that is involving these two sides. So tangent of theta will be equal to perpendicular by base, or some people call it adjacent, whatever you call it, up to you. So this way you can actually find out FBX, which is 3 tangent of theta in this case is 30. Okay, and you can actually calculate the FBX, which is the second horizontal force. So let me take out the calculator. We have 3 10 30. Okay, so it is around 1.73 kilonewton. Okay, so we found out this to be equal to 1.73 kilonewton. All right, now what have we found so far? Let's see. We found fbx, we found fby, and we also found fay. So we have found this one, we found this one. So two, one horizontal, one vertical, and then we also found another vertical force. Okay, now we are left with fax, sorry. So fax is the horizontal force component, and it must be equal to or the, the sum of forces in x-axis will be equal to 0. So if we do that by that way, let's do it here. So summation of f of x will be equal to 0, and you have only two forces that are in the x-axis. One is the fbx and one is your fax. Okay, so you can just do that. So fax plus fbx is equal to 0. All right, now your fbx is actually equal to 1.73. okay, so you can actually find out fax equal to now if you take this fbx as 0 as negative, because it is in the negative direction, so you can actually make it negative, and then when it comes to the other side, that will be actually become positive 1.73. So fbx and fax must be equal to balance each one out. Okay, only that the direction will be opposite. So this way we have found out all the four vertical components, or two vertical and two horizontal components of the reaction supports. Okay, I hope it is clear enough, and if you have any questions, please do put it in the comments, or ask me in the class, up to you. All right, take care. Bye. Thank you.